眠たくなっちゃうね。Hi, are you Paul? Jim? Hi, nice to meet you. Glad to meet you. So you need some tutoring in English? Yeah, I'm taking English composition and I'm not doing very well on my essays. Alright, well, first let's see if we can figure out a time to meet. That we are both free. Okay. How about Mondays? Maybe in the morning. I don't have any classes until 11 on Monday. That would work, but I was hoping we could, meet more than once a week. Oh well, Tuesday are out. I've got classes and I work at the library part-time on Tuesday and Thursday, but I could get together on Wednesday. In the morning, probably 9:30 would be best. That way we'd have an hour to work before I'd have to get ready for my 11 o'clock. So that would be 2 hours a week then. I could do that. Oh, but would that be extra? Would I need to pay you for the extra session? No, just so you meet me here at the learning center, and we both sign in. Then I'll get paid. Tutoring is free, to you, I mean. The school pays me, but we both have to show up. If you don't show up and sign in for a session, then I don't get paid, so... Oh, don't worry about that. I really need the help. I won't miss any session unless I sick or something. Okay then, so you want me to help you with your essays, right? I could bring you some that have, comments on them. I'm getting C's and, well, that's not too bad. Once I see some of your writing, we should be able to pull that F to a B. You think so? Sure, but I need to explain something. Some of my students in the past, they expected me to write their essay for them, but that's not what a tutor is supposed to do. My job is to help you be a better writer. Oh, I understand that. But you read my essays, right? Oh, yeah, no problem. We'll read them together and I'll make suggestions. Right, I think part of the problem is I just don't understand the teacher's comments. Maybe you can help me figure them out. Sure, who's the teacher? Simpson. No problem. I've tutored a couple of her students, so I know more or less where she's coming from. Okay then, I guess we'll meet here Monday. I'll be here 9:30, you said. Just sign in when you get here. Okay, today we are going to discuss the 4 major types of drainage pattern. I trust you've already read the chapter, so you'll recall that a drainage pattern is the arrangement of channels that carry water in an area. And these patterns can be very distinctive since they are determined by the climate, the topography, and the composition of the rock that underlies the formations. So consequently, we can see that a drainage pattern is a very good visual summary of the characteristics of a particular region, but geologically and climatically, in other words, when we look at drainage patterns, we can draw conclusions about the structural formation and rate of the land as well as the climate. Now, all drainage systems are composed of an interconnected network of streams, and when we view them together, they form distinctive patterns, although there are at least 7 identifiable kinds of drainage patterns for our purposes. We are going to limit our study to the 4 major types, Probably the most familiar pattern is the dendritic drainage pattern. This is a stream that looks like branches of a tree. Here's an example of a dendritic pattern. As you can see, it's similar to many systems in nature. In addition to the structure of a tree, it also resembles the human circulation system. This is a very efficient drainage system because the overall length any one branch is very short and there are many branches, so that allows the water to flow quickly and efficiently from the source over sources. Okay, let's look at the next example. This drainage pattern is referred to as the radial pattern. Radial. Notice how the streams flow from central points. This is usually a high mountain or a volcano. It kind of looks like the spokes that radiates out from the hub of a wheel. Spoke? What is a spoke? Spoke. Ah. Suppose that radiate out from the hub of a wheel. When we see a radial pattern, we know that the area has experienced updrift and that the direction of the drainage is down the slope of a relatively isolated central point. Going back to the dendritic for a moment, the pattern is determined by the direction of the slope of the land, but the stream flow in more or less the same direction, or so it's unlike the radial that had multiple directions of flows from a highest point. Now this pattern is very different from either the dendritic or the radial. This is called a rectangular pattern, and I think you can see why. Just look at all of those right angle turns. The rectangle pattern is typical of a landscape that's been formed by fractured joints and folds, and because this broken rock is eroded more easily than unbroken rocks, stream beds are caved along the joint bedrock. Finally, we have a trails pattern. And here in this example, you can see quite clearly how the tributaries of an enormously parallel structure drain into valley and from the appearance of garden trails. This pattern forms in areas where there are alternating bands of variable resistance. And by that I mean that the bands of rock that are very strong and resistant to erosion alternate with bands of rock that are weak and easily eroded. This often happens when a horizontal plane falls and outcroppings appear. Oh. This pattern falls in areas where there are alternating bands of variable resistance, and but I mean that the bands of rocks that are very strong resistant to erosion. Those bands of that are weak and easily eroded. This often happens when horizontal flame forward. And so, as I said, as a whole, these patterns are dictated by the structure and relief of the land. Relief of the land, that the kind of rocks and feature streams are developed and the structure pattern follows and follows. And uplift will usually determine a drainage system. However, I should also mention that the drainage pattern can occasionally appear to be, well, out of sync with the landscape, and this can happen when a stream flows over older structures that have been uncovered by erosion, or when a stream keeps its original drainage system when rocks are uplifted. So when that happens, the pattern appears to be contrary to the expected course of the stream. But I'm interested in your understanding the basic drainage system. So I don't plan to trick you with a test question about the exceptional patterns. But I expect you to know that the exception to the pattern can occur when geological events influence them. これ結構難かった。